Today we're going to talk about how to install the EZ5160. So I need to obviously point out a couple of things here. Obviously you can use the stepper on several of these ports, being 10 of them, but you can only use the end stops on 6 of them. But normally you're only going to use one direction for your end stops. So what I'm going to show you how to do is, first of all, how to deal with the power issue that you may see over in here for this particular stepper, because it has a different voltage range that I'll show you, but I'm going to be using 24 volts, but you can vary the power supply to this for your steppers, but you have to do all the same for the same type of stepper in this case. So what I'm going to do is, first of all, show you where you find the information. So I'm going to take you over to my desktop for a second, and I'm on the Big Tree Tech website. So I'm going to show you repositories. First, we're going to search on the board, which is the Octopus Max EZ. You can actually download this using code and then download and then extract it on your computer. The other place that I want to show you is actually the EZ steppers. So we're going to search on EZ, and this will bring us to the stepper driver information. Now I've already pulled it down for this whole entire folder. So I have the actual folders open on my computer, which I'll show you in just a second. So obviously I've already downloaded and extracted the Octopus Max, and you can see that there's actually information about steppers that'll be in here. So if we scroll down just a little bit, we'll be able to find the steppers. So one of the tricks that I like to do is actually Control F to find it, but it's right here. So I'm just going to click on it, and we're using a serial peripheral interface stepper. So we're going to have to set probably not the sensorless homing, because I'm not sure at this moment if we can use that. So I'm going to show you with an end stop. And then we have our voltage settings over here, for high voltage being these 2 pins, and then lower voltage being these 2 right here. But I'm using 24 volts of power, so I just want to show you that version. So the other thing that I have is actually the manual that I pulled down. So if we search on, let's see, I think it's SW_SPI. Let's see if we can find the information. So there's one reference. So this talks about the actual SPI settings that we're going to need to set. Now there's other settings that we have to talk about, and that's the resistor sense has to be different. So the R sense in this case is going to be 0.075. So what we're going to do is we're going to go over to VS Code to set this up in just a moment. So I'm going to open this up, open a folder. In my downloads folder, I've already downloaded 2.1.2.1. So I'm going to open up both folders, then select the folder. But real quick, I'm going to go over and check the actual manual again here, because there's some information up here that we're going to have to look at. Now they're going to talk about in here the actual power usage that can be used with this. So you can see that down here it's ultra quiet. I believe it also has some more information, but you can see that it can go up to 48 volts. So I wanted to keep that as something that you could see. Obviously, there's going to be a different set of information that you're going to have to look up in here if you're doing something special. So I just wanted to make these things clear for you. So what we're going to do is go over to the board for a moment and set up the actual jumper. So I'm going to grab a pair of tweezers. I'm going to grab this, and I'm going to insert it up here for the lower power of 24 volts that we have set up in here. Obviously the voltage is coming off one PSU or power supply unit, so you can see the voltage is positive for each one of these written on here, and I've double checked that. The next thing that we need to figure out here is how to insert it. So this part right here is going to face you. So you're going to put this in here and just put the pressure down to install it. So you can see that the bolt side is right here. Next, what we need to do is actually set up the end stop right down in here. So I have to show you that. Obviously, there's two wires on here being red and black. In this case, we're going to use the red as signal. So if we go back over to the computer for a second, I'll pull up the diagram of the board so we can see it. So you can see that we're going to use the X stepper being the first one, min 1. And we have a signal pin, which is PF0, G, which is ground, and then 5 volts. So these are the pins that they're referring to. So we need to set it up on the signal and the ground for this particular type of connector. Yours may have all three here, and you'll have to align the pins as such when using it. So let's go back over to the desk for a second here. I'm going to grab the cable. I'm going to insert it in those two pins so you can see how I have it configured here. I'm going to insert this as well for the actual power source for the stepper. In this case, it's the NEMA 17, and it's currently unplugged for power. We have the end stop here. What we're going to need to do now is load firmware. So I'm going to pick this up, being the SD card, insert it in here, and then place this in the computer where you may hear a beep. Now let's go back over to the desktop. We'll go over to VS Code, and we're going to set this up. So we're going to go to Marlin Source Core Boards.h. Inside here, we're going to search on Octopus, and we're going to find ours down here. So we're going to highlight that, right click, and we're going to copy it. Notice that there's two different chipsets for the PSU, and I'll show you what I mean by that. The PSU on this board is located right here, and it has writing on it for STM32 something. That is the one you're going to have to use for your configuration. It may change in the future. So if we're back over here, we're going to minimize source, go to configuration.h, scroll down until we can find the actual board type and paste over it. Next, what we're going to need to do is set up our board, which is going to be -1 for our serial port in this case. So you can vary it between these two. This could be your board, but I usually use this for the display. That's why I changed this one. And obviously there's speed right here. So now we're going to search on A4988, and we're looking for the STM5160. So I'm going to copy that right here and paste it for our X-axis. So that is now set up. Now there's a couple other things that we may need to set up down here that I might not be able to find right away without searching, because they changed the order of things. So what I'm going to do is I'm going to search on the stepper by doing it's steps per something, but I'll search on 80, space 80, and that'll bring us to default axis steps per unit. So in this case, it's defaulted to 80. Now it's going to be unique when we go over to advanced configuration and search on 800, which will get us in the neighborhood of the X current. Now there's some things I need to point out for your steps. It's going to go between either 16 and 256 of a step. But the reason that I'm going to point this out is currently it's 80. So if we change this to 160, we will need to change this one to 32. If we change it to 320, then we're going to need to change this one right here to 64, and so on and so forth, all the way up to 256 of a step if you're going to go that high. So that is something that I need to point out because there's always confusion around it. Next thing that we need to do is actually set the resistor sense, which we just looked up, and that's going to be 0.075 for our value for our resistor sense. That was the one we found in the manual just a moment ago. Now we're going to set up debugging. So I'm going to search on TMC_debug. I'm going to remove the debug here with control / so we can use it. And I'm going to find the second one. When you're done with this, you can always remove the debug statement if you want. So I'm going to do control / again on this line. And then I'm going to double check the other one just in case I commented it out by accident. So that's set. Now this is obviously SPI or serial peripheral interface, so we need to set the values for that. And if you watch my previous tutorial for the TMC or EZ2130, we're going to have to search on SW SPI, I believe. There we go. And this will be what we need to uncomment with the control /. This points to the pins that are in our pins file. So if we go to source, pins, down here, find our board type here for our MCU, we can see that it's right here, and those values will show up that we're looking for. So essentially the values that we're looking for are like chip select for PG14. That will be contained in here if we search on PG14. So let's see if we can find it here. I might have set it incorrectly, so let's see what we can do here. So PG14, that's PC. It's PG, so I didn't put in the correct letter. So there we go. So that's our chip select pin. So your other pins will be in here and you can find them, but I'm just pointing out the process of how they outline it in your pins file that points to your MCU. So let's go back to the advanced configuration. Looks like we've got this set. We can't do sensorless homing at the moment because I'm unsure it will work. That's why we're using an end stop. So let's set up the build. So we're going to go over here and it's platformio.ini. So we have the wrong chipset. So what we need to do is we need to change this. So we're going to go to the ini file. We're going to find our board and we're going to search on Octopus. And as you can see right here, here's the first reference to it. This one doesn't work for me, so I'm using the second one because my chipset seems to not work. There may also be a build issue with this particular one, but we'll figure that out some other time. This is just to show you the process for setting this up. So we're going to go to Platform.io, highlight the Mega 2560 chipset, and paste in ours. Next, what we'll do is we'll click the checkbox to build. This may take a few moments. It will populate inside of here, so you can watch it as it builds. This will actually fill. Now, if there's an issue, what we'll see is red in here if it fails. Yellow is a warning. If it fails the first time on red, what you'll do is you'll hit the build button or compile button again to rebuild it in case something built out of order. If it doesn't work after the second time, find the very first time that you see red and then click Control and the mouse pointer on where you see the actual red, and that will take you to what the actual issue may be. Here's an actual warning, which we can ignore. So what we're going to do next is we'll see our firmware.elf and then firmware.bin populate in here. Bin is actually binary. That's what it means in this case. So what we're going to do is right here, we'll click on it. We'll right click and say Reveal in File Explorer. And what we'll do is we'll place it here. Here's our last known good build that installed. It's in all capital letters. So we're going to right click and we're going to send to that drive. So if this is successful, it will be renamed to this. If you ever want to reload your firmware.bin, you rename it to this. So you can also use that for like configurations on other boards. But just keep that in mind that successful is firmware.bin with a file size. So let's pop this out and actually install it. So take this out of the computer, take the SD card, pop it in here, then take the USB, which is not powered at the moment because I left the jumper off because it resets these steppers. And we're going to plug this in just a second. So I'm going to power this up. The firmware should load. Hopefully we hear a beep on the computer. And then what we'll do is we'll go over to Pronterface and actually test this out. So on the computer, as you can see, we have Pronterface up. It's already defaulted to the correct USB configuration, which you can test by clicking here and typing Device Manager. And it'll bring up the actual COM ports right here under COM ports. And we can see that it's our chipset for the STM Microelectronics virtual COM port for COM port 23. So let's try and connect. It says the printer is now online. So let's check the end stops real quick. So we'll type M119 and press enter. You can see that it says open. And we'll also check with M122 the status of the stepper, which says okay at the moment. So we've got these both checked. So what we're going to do next is we're actually going to check to see the end stop works correctly. So I'm going to actually have to use this command down here a second time. So I'll press enter on this when it comes up. But first I'm going to show you what I'm doing. So I'm going to move this over to the center for a second. I'm going to click this down right here to verify it's locked. And then I'm going to press enter on the M119. And you probably can't see it, so I'll make it visible after I take my finger off. So let's go back and make this more visible. Give me a second here. There we go. So you can see that it's triggered. So the end stop was correct for the next click where I had my finger on it right here. So now let's test the actual stepper and the end stop together. So what I'm going to do is I'm going to home the access. Hopefully it'll go in the right direction. If not, we can correct that in the firmware, and I'll show you how to do that in a second. So I got my finger on here, so if it reaches the end of the access, we can click it. So I'm going to click here. Whoop, give me a second here. And we can stop it. Then we can move it forward if we want 100. Hopefully. So apparently we've got an issue where it said that it failed. So what we're going to have to do is we're going to have to power cycle and try this again. So I'm going to power cycle it by removing the power, connecting it again. Then I'm going to reconnect over here, and I'm going to try and home it and double click with my finger and hopefully do this correctly. Okay, so what was the issue was, I'll show you in here. I didn't double click with my finger when I was showing you, and that's why we got this confused message up here where it failed. So this kill occurred because I only clicked once. So let's see if it works now for stepping out. So we'll click over here for go out 100. And that appears to be correct. So we can go out 10 if we want. And then we can home it again. And I have to double click with my finger when this happens. So we'll click home. And we'll double check to see that it's correct inside of the actual display. So it does say processing, but I just double clicked it a second time to make sure. So hopefully this works. So let's try stepping out and seeing if it's okay. So it is. So what you can't see normally is the double click when you test it yourself, unless you do it really quick. But at this moment, I'd like to thank everyone for taking the time to watch the video. And please remember to like and subscribe. And I'll also place a thank you note to the patrons that have been good enough to patronize my Patreon page as well as pay on PayPal, with a thank you note at the very end of this video. So everyone take care, be safe, and I'll talk to you later.